Okay, hey guys. Wow. Been looking at this stuff. Pulled a bunch of them up this morning, and I thought I'd wait to see if this stuff changed. 'Cause there's a bunch of missing time here, but it would appear that things might be getting back to normal. If you watch this, I got the L shell pulled up. This is the only one that's updated. All the rest are cutting out on 11.8, 1700, somewhere around there. Watch this, 11.9, 1940. Then we got missing time till 11.10, 13. So that's like 16 hours. But when it came back online on 11.10, around 13:43 or something, all this white stuff's gone away. And this is only 10 to 100,000 to 400,000 electron volts. So watch this. Here's 11.8, 11.9, 19. Then it rolls to 11.10, 13. And then all of a sudden, everything gets back to normal color-wise. So I pulled these three up because these are the only three that fall within this range. So, I don't know. I'm at a loss there. They got 16 hours of missing time, and then everything seemed to go back to normal, but it did it in like an instantaneous fashion. Watch again, 11.9, 19, and 10:13. And things start getting normal, and then by 10, 11:10, 1800, went back to normal. Crazy stuff. Same thing on all these. This is at 2 MeV, C11, 11.9. So that would have been yesterday at 1940 UTC, 11.9, 2020. Then all of a sudden, 11.10. Everything flips back on, like flips the switch. Here's 4 MeV, same thing. Back to normal colors. Same deal at 1 MeV. I mean, normal for what we've been witnessing for the last 8, 9 months anyway, since I've been looking at this stuff. Same thing at 425. Went back to normal. And these all show the same. So save time. We'll just stop there. Here's the latest run on ISWA with the magnetosphere. Solar wind's been jumping up and down. It went up to 4 digits, I think, once in this run. And it's best to click this box down here to get the full screen view. Just hit the box and then allow once, and watch this thing full screen. You can see an 800 something, 800 something. It's been running basically around 600, 700. But every once in a while it jumps up to 8. There's a 9. Now these is all solar wind speed being measured in here by these. There's another 8 and a 9. Rolls back over. They're all being measured by these GOES 13, 14 satellites in here. That's the ones that are feeding all the data for these simulations here. And you can see, watch here at 11. Well, unfortunately, we don't have the, this thing doesn't go back as far as 11.9, 19, 20, or 40 whenever we had that mission time, and then it jumped to 11. 10, 13, 48. So, but there was some stuff going on back here. I could see why maybe they didn't put that stuff back online yet, those energy things. You can see I got a whole lot of energy there, and we So magnetopause is getting all bent out of shape. But by 11:13:48, that's when it went back online for these energy things. And that's when it, I mean, it just weird how it just went. There it goes. 11:09, 20:20. Everything's still looking pretty weird with all this stuff whited out, which would be super high energy in my opinion. But unfortunately, the other radiation belts, they only go up to 11:8, 1700, or 2100, depending on which one you look at. But well, all on 11:8, so they really are no help. And then watch this, how it just bleeds in and then blam. It's like everything just shifted, like someone turned on a switch, and there's no missing time there. It's 11:17, 11:16, 56, 17:16, and 17:28. So within the course of 12 minutes, just flip the switch. I don't know. Crazy stuff. So let me start this thing playing again. Whoops, I missed it. And these, they're basically the same deal. There's the 4MEV, 11:9. See, everything's going along. 11:9, 1820, 1900. Still got the pastel greens and pinks. 11:9, 1940, UTC, 2020. Then there we go, blam, 13:28. So that's like 17 hours. And same thing on this one. And then just normal after that. Same with this, just normal. Just normal after that. I mean, normal from what we've been seeing anyway. So I pulled up Discover to see what the heck's going on. This is 3 days. You could see there's a whole bunch of flux all the way up until, there's the time up there, 10:56, 10:40 UTC on 11:9. See, we had all this instability in the interplanetary magnetic field between the sun and the earth connecting, and the earth and Nemesis connecting. So everything above 180 is sun to a solar body behind the earth, or I'm sorry, the earth to a solar body behind our planet. Anything above 180 would be indicate a connection with Nemesis behind us. Anything below 180 is either a sun to earth connection or an earth to sun connection. So you can see there's a whole bunch of stability for all of November 8th up until mid-November 9th, and all of a sudden we got a steady reconnect back to, why does this do this? Okay, I pulled it back up so you can see steady reconnect around 10:56 UTC on 11:9, 11, and then all of a sudden we got a strong connection with something behind us, behind the planet, Nemesis, another solar body. Those numbers are all up in the high 300s for the most part. And our solar wind's been coming up ever since. And here's one thing I noticed. Now, remember the solar wind density I we found out earlier that it was normal between 4 and 6. This is the density here, 4 and 6 atoms per cubic centimeter. So look, when the sun's solar wind speed goes up, and this is what I theorized earlier, that keeps the density down. But then when the sun's solar wind speed, our sun, solar wind speed goes down, see how the density comes up? That's because we got that solar wind coming from Nemesis, so everything starts piling up. And this is out at the L1 Lagrange point, 930,000 miles in front of the planet, where this Discover satellite's parked. So we had like 3 times density, normal density up there. But then once the solar wind speed started picking up again, look how the density comes down. So I'd say there's probably pretty constant solar wind around 500 kilometers per second coming from Nemesis, reaching out as far as this 930,000 mile. Here's the diagram, L1 Lagrange point. This is out where Discover is. So theorizing we have probably about a 500 kilometer per second constant solar wind speed coming from Nemesis, reaching out as far as this point. That's what these density and solar wind speed numbers would suggest to me. So running out of time as usual. So this solar wind speed we got in here, it's all being measured by these satellites inside of here. You can see the magnetoposits getting all spaghettied out. So see these numbers here? Now I think they're getting accelerated by once they come in within our magnetosphere, magnetopause, and get inside those L shells. And there's a lot of different magnetic turbulence going on inside this magnetosphere. Remember, those L shells were each L shell was a Earth radii. So there was 8 L shells. So figure here's 0, here's the Earth. So count 8 from out here. 1, 2, 3, 4, 5, 6, 7, 8. So those L shells extend down to about 9 there, about 9 up here. That's basically what those L shells are reading, those Fock radiation belts. So once this Nemesis solar wind gets up inside here, and there's all those different L shells which indicate magnetic field lines, strong magnetic fields, I would say. It's just getting jumbled around and accelerated. That's why these numbers fluctuate so much. And of course, whenever we make a direct connect with a coronal hole stream from Nemesis, that's another story. That's when the solar wind gets up into the 1400 kilometer per second range. Nothing showing on MLS though. They didn't give us anything today. I looked at the one yesterday. Pretty much the same with what I've been showing you. Definitely need to click the box down here for this one. Here's the latest Himawari 8. It's still showing, but barely. You can see this stuff's pixeled out down here still. You see that little light beam? So whatever planet, and there's some light showing there. So whatever the planet that passed our geosynchronous satellites, so you can hardly see anything now. It's pretty much out of the picture on these weather satellites, which travel around here. Well, they're geostationary, geosynchronous orbit. So one's up on one side of the planet, the Himawari 8, say, and then the GOES 16's down here, shooting different sides of the planet for weather purposes mainly. Oh yeah, geospace. Here's the velocity, because our solar wind's up, so you can see we're getting buffeted. And this is the last 3 or 4 hours on, and as you can see, it pretty much corresponds. See those little spikes there in the solar wind? It takes about maybe an hour, 15 minutes to an hour for this stuff to reach these geosynchronous stuff. Anyway, running out of time. God bless, peace, and I'm out.